Okay, the law says that the power of a quotient is the quotient of the powers. So it says here in algebraic representation, as you can see here. I'm going to prove that using an example first. We have 5 raised to 7 divided, not raised to 7, sorry for that. Five divided by 3 raised to 5, for example, is equal to 5 raised to 5 divided by 3 raised to 5 according to the law. Then I'm going to prove that. Why? Because once again we have a raised to 5 is the same as a times a times a times a times a. Then we have, if this is, the parenthesis is our a, then we have 5 divided by 3 multiplied by 5 divided by 3, and then 5 divided by 3, and then 5 divided by 3. One more time. Then as you can see, 1, 2, 3, 4, 5. There are 5 5s, 5 raised to 5, and then, sorry for that, looks like, and then 3 raised to 5. There are 5 3s also. Okay, so for example, you have a divided by b raised to 3. Then we have a divided by b multiplied by a divided by b and a divided by b. Then we have a raised to 3 divided by b raised to 3. Next law, it is a raised to 0 is equal to 1. Before I'm going to prove this, then I will remind you that we have a raised to n divided by a raised to n is equal to a raised to m minus n, the second law that we have discussed, this one, that law. That is, I am discussing here also. It's very important that you remember that. Okay, so if I have here a divided by a, we know that this is 1. When the numerator and the denominator are the same or are equal, then the quotient is always 1. Then if I have now here 2 raised to 2 divided by 2 raised to 2, then we have 2 raised to 2 minus 2 according to this law. Then we have 2 raised to 0. And as I said here, when the numerator and the denominator are the same, then we have also 1. Another proof is that we have 2 raised to 2 is 2 times 2, and 2 times 2 is 2. So that is 1, that is 1. Then we have 1. So 2 raised to 0 is equal to 1. And this applies to any number. For example, a raised to m divided by a raised to n, that is a raised to n minus n, that is a raised to 0. And a raised to 0, or when the numerator and the denominator are equal, then you have always 1. This is a little bit abstract for many of my students, so be careful with this. And then the third, the last one, I guess, not the third, no? Yeah, the last example or law, not example, law that I'm going to discuss is this one. Negative exponent. So if we have a negative exponent, is equal to that one. Or the other way around. 1 divided by a raised to negative exponent, it will become a raised to positive exponent. Okay, so we will, in particular, this one. Okay, we will try to do an example. So for example, we have a raised to 3 divided by a raised to 4. Then we have a raised to 3 minus 4 according to the law, the second law that we have. Then we have a raised to negative 1. But if we expand this, then we have a times a times a. And if we expand this, we have a times a times a times a. So we have this will be 1, this will be 1, this will be 1. Then we have only 1 left in the numerator, and denominator is a. So that means this one is equal to this one. So if you have negative exponent, then it will become a denominator, and the exponent will become positive. Let's take another example. B raised to 2 divided by b raised to 5. Then we have b raised to 2 minus 5 is equal to b raised to negative 3. If we expand both the numerator and the denominator, b times b, and then b times b times b times b times b, then this will be 1, this will be 1. Then we have 1 divided by b raised to 3. So b raised to negative 3 is equal to 1 divided by b raised to 3. Remember that. You can kick, I usually say that you can kick the b raised to negative 3 under, and then it will become positive. But remember to write the numerator as 1. Okay, what happened if we have negative exponent there? So for example, 1 can be write as any number, like 1 times a raised to 0. We can write like that because we have a raised to 0 is equal to 1. So this one, we can write 1 is equal to a raised to 0. So if we prove this one, we have 1 divided by a raised to negative 3. It should be a raised to 3 according to this law. Why? Because 1, if a raised to 0 is equal to 1, then we have a raised to negative 3, then we have a raised to 0 minus negative 3. Sorry for that. They are screaming outside. And then we have a raised to 3. That's a proof for this one. It's a long video for this time, but it is worth. For my next video, then I will be solving more examples. See you around.